These notes are over 4.2 and 4.3. 4.2 is called the case of the missing diagram. The essential question is, how can I identify the given or givens, the conclusion, and the diagram from a word problem? So sometimes you'll be given a word problem that doesn't have any pictures, it doesn't tell you what's the given, what you're trying to conclude, and you have to come up with that on your own. So if you're presented with a word problem, there are 3 things you need to be able to do. You need to be able to write the given or givens. This can usually be found in the sentence, either the first part of the sentence or the last part of the sentence. The other part of the sentence will be probably the conclusion. You'll also need to draw a diagram that shows all of your givens. And then, of course, write your conclusion, which is the other part of the sentence. So let's try this with an example. So here's an example. The sentence says, the altitude to the base of an isosceles triangle bisects the vertex angle. If you can find that word, that verb, which in this case is bisects, that'll usually split your sentence into 2 parts. Usually one part is the given or givens, and the other part might be the conclusion. So what we've got an altitude and an isosceles triangle, and the altitude is bisecting the vertex angle. So we first need to, I always try to draw the picture first so I could see it, and then write the givens from there. I know I've got an isosceles triangle, and I can show that with 2 ticks to show the 2 sides are congruent. It says the altitude to the base, so we need to draw in that. The base is going to be that 3rd side that's not congruent. The altitude, remember, goes from the vertex, or a vertex, to the opposite side at a right angle. So it's just going to go straight down and make a right angle. I need to go ahead and, so it looks like what I'm drawing, that's going to be what's given. So we'll say that this first part of the sentence here is our given. So let's go ahead and write down some of our givens. Sometimes givens are shown in the diagram, so your given could be C diagram or as shown in diagram. But we could also write down some of these things. We can write it in a couple different ways. We could physically write down that we have an altitude and that we have an isosceles triangle, or we could interpret those and think about, well, what does that mean? So I could say instead, and I need to probably put some letters on my picture, maybe we'll just put A, B, C, and D. I could say BD is an altitude. I could say angle BDC is a right angle, and then you could conclude that therefore it is an altitude. I could say that side AB and side BC are congruent, which means that you could conclude that it's an isosceles triangle. I could say that what else could we say? We could say this in a couple different ways. So probably what I'm going to do is, let's go ahead and say, and this could be different for each person. I'm going to say AB is congruent to BC, which is why I have an isosceles triangle. I'm probably just going to say angle BDC is a right angle. But like I said, you could also say BD is an altitude. So there's a couple ways you could say these givens. Now my conclusion is going to be the other part of the sentence. The other part of the sentence says bisects, and that goes with the subject altitude. So the altitude bisects the vertex angle. Now the vertex angle is this angle up here. It's the angle between the 2 congruent legs of an isosceles triangle. So maybe that's our conclusion. And I could say that a couple different ways. I could say BD is a bisector of angle ABC. I could say Well, what does a bisector do? I could say, you know, I've got two congruent angles. Angle ABD is congruent to angle DBC. So I could say this conclusion in a couple different ways. So just pick one of them. This is up for interpretation. I'm just going to say angle ABD is congruent to angle DBC. All right, so that's about it. Just use what you know, try to draw what you've got as best you can, come up with some kind of a conclusion based off of what's given, and just do your best. Let's go ahead and look at 4.3. 4.3 is called a right angle theorem. The essential question is, how can I prove that angles are right angles in a new way? So we've already proved that we've got right angles in a couple ways. We know altitudes give us right angles. We know perpendicular gives us right angles. So let's learn another way. Here is your right angle theorem. If two angles are both supplementary and congruent, then they are right angles. This is probably something we've already talked about in class that you already knew. So if two angles add up to 180, they're supplementary, and they have to equal each other, they're congruent, then they both have to equal 90 degrees, which means they're both right angles. So this makes sense. So you would want to use this as a reason and a proof after you have stated that two angles were congruent and assumed to be supplementary because there's a straight angle there in your picture. Then you can say they're right angles because of this theorem, and unfortunately you would have to kind of write it out. Let's try a proof with this. Yes, proofs aren't going away just yet. I know y'all aren't too sad about that. Okay, so here's a proof. We're told a couple things. We've got this picture, a proof statement. This is going to be kind of a long proof, so I'm going to have to probably somehow squeeze it in on this page or erase it or something, so we'll deal with that in a minute. But let's go ahead and see what we've got. We know that AB is congruent to AD. We know that BC is congruent to CD, and that's all we know. We're trying to prove that AC is a perpendicular bisector of segment BD, which means that it makes a right angle with BD and it cuts it in half. In order for it to cut it in half, that means BE and ED would be congruent. So somehow we're going to need to say that, and we're going to need to say that we've got right angles there. Well, we've got this right angle theorem, and that says that if angles are supplementary and congruent, then they're right angles. Well, I can see that the angles, you know, here, those are supplementary, clearly, because that's a straight angle. Together they form a straight angle. But if I could show that those are congruent, then I could show that they're right angles because they'd be supplementary and congruent. We can use that new theorem. So we've got a couple of things to do here. If I think back to last chapter, we did a lot with congruent triangles. And I've got a lot of triangles in this picture. Based off of my givens, I can kind of look at, let's see. If I look at this triangle right here, I could very easily say that it's congruent to this triangle here by saying that AC is congruent to itself by reflexive property. And then perhaps after that I could maybe use CBCTC to state some other things. Let's kind of go with that plan. So let me erase all that stuff. All right, so let's go ahead and set this up. Statements, reasons. Let's go ahead and start off with our givens. AB is congruent to AD, and BC is congruent to CD. Those are both givens. We also just said that we could say AC is congruent to AC itself because of the reflexive property. that would be enough information to say that we've got two congruent triangles by SSS. So we've got S, S, and S. So by SSS, we can state that these two triangles are congruent. So maybe we call the top one triangle ABC, and the bottom one maybe ADC. And I need to show in my picture that AC is congruent to itself. Okay, so if those two triangles are congruent, what else do we know? In order for me to say that AC is a bisector of BD, which is part of our proof statement, we actually have two things to prove. Not only does it make a right angle, it's perpendicular, but that it's a bisector. We would need to say that BE and ED are congruent. Well, BE and ED are not part of the two triangles we said are congruent. But perhaps by CPCTC, I could state enough information about these two triangles that I've already proven congruent to then say two other triangles are congruent. And therefore, by CPCTC again, we could say BE and ED are congruent. So perhaps we go that route. Let's see what else we know. If we look at two other triangles that might be congruent, we could talk about these two triangles being congruent or these two triangles being congruent. And it's really, you know, one or the other. I don't think one is going to be necessarily easier or harder than the other. Let's just go with those first two. For those to be congruent, we would need to state two other things. We see, and oops, this is supposed to have two ticks. We see that BC and CD are congruent. Okay, that would be a side. We've already stated that. I know EC would be congruent to itself because of reflexive property. We would need to say one other thing using CPCTC from our two original triangles we said are congruent. And the only thing we could say is that this angle right here and this angle right here are congruent. Now, let me rework my marks. They're not so pretty here. All right, let me go back. Okay, so what did we say? There's two marks here. So we could say this guy's congruent to itself, EC is congruent to itself, and we could say this angle and this angle are congruent because of CPCTC from the two original triangles. So let's go ahead and state those. EC is congruent to EC because of the reflexive property. Angle BCE is congruent to angle DCE because of CPCTC. So what we've got another S. Our first S that goes is this S. We've got this other S. We've got this A. So by SAS, we can state that those two triangles right here and here are congruent by SAS. So maybe we'll call the top triangle triangle BEC, and we'll say that it is congruent to triangle DEC. Okay. I'm going to kind of erase this part of my proof, so just kind of come back to this page if you need to. Just rewind a little bit. Okay, let's first talk about the bisector part of the proof statement. AC bisects segment BD. And what we said earlier is that we'll have to state that BE is congruent to ED. Now that we've said those two yellow triangles are congruent, we can state that those are congruent by CPCTC. So that'll be the first thing we're going to need to do. And that's by CPCTC. Okay. So because of that statement alone, we can say that AC is a bisector or bisects BD. So let's state that. There's going to be two parts to our proof statement. That's the first part. AC bisects BD. And the reason we know that is because definition of bisect. We've said that its two halves are congruent. So this is one part of our proof statement. We still have to say that AC is perpendicular to BD. So in order for us to say that, we need to state that we've got a right angle at that intersection right where E is. And we can state that by our new theorem, which says if two angles are both supplementary and congruent, then they're right angles. Well, we know these two angles here. Let me get another color. Bear with me. We know this angle and this angle together are supplementary because they form that straight line. I don't need to say that. I'm not requiring you to state that two angles are supplementary. By this point, I think we can assume that. But we do need to say that they're congruent. And I know that they're congruent because they belong to two congruent triangles. So we can say angle BEC, excuse me, let me go back to my other color. Angle BEC is congruent to angle DEC, and that's just by CPCTC as well. So because they're congruent, we can assume they're supplementary. Now we can say those are right angles. Angle BEC and angle DEC are right angles. And this is where we get to write our new theorem. Yay! If two angles are both supplementary and congruent, they are right angles. Okay, and if they're right angles, we can say that AC is perpendicular to BD, which is the second part of our proof statement. AC, perpendicular, BD, definition of perpendicular, and we are done because we have the two parts of our proof statement. So that was a pretty long proof, but if you take it piece by piece and kind of think through it, how do I connect the givens to the proof statements, you will get there. So that's it for the notes. If you would like to work ahead on some of the problems that we'll work on in class, these are the problems for 4.2 and 4.3. A hint on 4.3, number 4 here. The hint is that you have an isosceles triangle, or think isosceles triangle. Okay, love you guys. See you in class.